Okay, we're going to look at Marika's problem, and we're just going to work through this. This is a full-fledged example of a type of problem that you would encounter, but it's quite simplistic, but it's a good starting point for what we're going to be doing. So when you go through these problems, the first thing that you're going to have to do is identify the variables that you're looking at. And we've read and done this problem, and we know that the variables, I told you that the variables, so that for consistency purposes, we would use X for the pastels and Y for the watercolors. Just so that we're all doing the same thing. And then the next thing that you have to do is create the inequations to represent the two constraints Marika has. Now, we're going to use 4 constraints, but the main constraints actually that she has have to do with time. And basically, she says that she figures she has time to make no more than 16 pictures. So pastels and watercolors are the pictures that she's going to be painting, and she has time to make no more than 16. So the constraint for that is X plus Y is less than or equal to 16, because the number of pastels plus the number of watercolors cannot exceed 16. So less than or equal to 16. Can be 16, can be less than. The second constraint that we're dealing with in the picture is cost. Now, the materials for each pastel cost $5. Materials for watercolor costs her $15. And then Marika's budget only allows her to spend $180 on materials altogether. So the constraint for costs is this one. So 5x plus 15y cannot exceed $180 because that's all she's got to spend. And so that's really the second constraint. So these are the major ones here. And then the minor ones we still pay attention to, because basically they'll help us sort of sort out our graph a little bit better, is that we know that we can't have pastels in the context of the question be, be negative. So we'll say that pastels have to be greater than or equal to 0, and the watercolors have to be greater than or equal to 0. It's just a way of sort of confining our area or our feasible region so that we know that we're not going into the negatives for the context. Once we've done that, we will then go into Desmos and we will plot those constraints on Desmos. And basically, excuse me, we will shade appropriately. We will draw sort of one thing at a time so that we can show, you know, X is greater than or equal to 0. We can show Y is greater than or equal to 0. We can show the next graph. And remember that when you go to create these graphs on paper, you've got to get a couple of points and you've got to draw your line in accurately. So that green line has to be duplicated onto your paper 100% accurately. And then, and you can be doing this sort of one at a time if you want. Just draw the line in with a couple of points and then shade. And then what you end up doing is, once you've got these all ticked, is you end up getting your feasible region in here, contained within those 5 points. And then you identify your vertices within that feasible region on Desmos, and then you go back to your paper and you basically shade away and draw on your paper exactly what Desmos has done, but you're shading away so that you end up getting your feasible region to basically be a blank, uncolored or unshaded area with your vertices identified. So this can't be done haphazardly. This has to be done 100% accurately by grabbing some points and accurately drawing the graphs. The straight lines have to be drawn, accurately 100% with a ruler. And then you have to shade out so that you will get your feasible region to be a blank space, and then identify your vertices. So that's all done, and then you do your graphing. And then once you've identified your points of intersection in that feasible region, the last thing that you do is you're going to be using those to figure out the answer to the question. So the question is basically, we want to use the points of intersection to identify which combination of paintings will maximize her profit. So basically, Marika wants to maximize her profits at the fair by figuring out and making a decision about what combinations of paintings she can sell given her constraints. And somewhere in the question, you will be given something called an objective function, which will either deal with maybe maximum profits or minimum costs or whatever. And in this case, it's about profits. So she will be selling her pastels for $40 and her watercolors for $100. That's your objective function. That's your profit function. So you're going to write that as your objective function. So we're going to go 40x plus 100y is going to be equal to our profit, right? So this is going to give me my profit. So what I'm going to then do is I'm going to test each one of my vertices into this objective function to see which one maxes out the profit. So I'm going to use the first point. I'm going to go 40 times 0 plus 100 times 12. And I'm going to work that out and get a profit of $1,200. And then I'm going to test 6 and 10, and I'm going to go 40 times 6 plus 100 times 10, and I'm going to get $100. And then I'm going to test 16 and 0, and I'm going to figure out what that is. 40 times 16 is 640. So I don't need to test 0, 0, that's just silly, but you would test all your points of intersection and you would figure out which combination of pastels and watercolors gives you the maximum profit. And in this case, if she were to sell 6 pastels and 10 watercolors, she would maximize her profit at $2,400. So there it is. That's the solution. That's the answer to the question. And you would write a statement down here in context around that. And that would answer and finish the question off.